The more we learn, Weisman continued, passing his rubber band ball from hand to hand, the more we begin to realize that everything we take for granted, our concepts of space, time, matter, energy, gravity, everything, is just a very, very unique special case that really only holds together on a planet composed of crustaceous rock and water on an orbit with a radius of approximately 93 million miles around an average-sized G2 class white star, at a time about 13.5 billion years after the massive explosion that formed both the planet and the star, and the rest of the universe for that matter, all viewed from the perspective of moderately intelligent Homo sapiens. He looked up at Swan. Follow? Lost me the minute you picked up that ball. Swan grinned. Okay, let me try again. Weisman answered. Take this ball. He held it out before him. You perceive it as solid and stable. Yet at a quantum microscopic level, it's anything but. In fact, it's quite unstable and chaotic, mostly empty space, with billions of particles floating around in probability functions wavering between states of energy and matter, trying to decide what positions and momenta to assume. It's only from our blunt macro perspective that it seems solid. Okay, Swan responded tentatively. Now, here's a doozy. Weisman rolled his shoulders back, straightened his spine, and paused. We're waiting, Jules. Altieri chided him. I'm trying to figure out how to say it. He took a deep breath, cracking his knuckles. Well, so, those particles occupying that empty space, they're not there until someone observes them, at least according to Bohr. Huh? Remember that story teachers used to tell in grammar school science? If a tree falls in the forest and there's no one there to hear it, it makes no noise. Swan finished his thought. Exactly! Weisman snapped his fingers. A particle only exists as a wave of probability until someone actually observes it. Then it becomes real. So you're saying that our minds create the universe?